Hi everyone. In this video, I'm going to cover the basic law which help you to measure the loop current in the circuit analysis chapter. The mesh analysis. Before diving into the mesh analysis, the law which help you to analyze the circuit is Kirchhoff voltage law. The statement of Kirchhoff voltage law states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drop within the same loop, which is also equal to 0. So in other words, how we can say is algebraic sum of voltage drop across a loop equal to 0. So this is the shortest remembrance of the KVL, Kirchhoff voltage, algebraic sum of voltage drop across a loop equal to 0. It also known as the conversion of voltage. So this is the mesh analysis. The picture and representations will give so how they were measured the voltage drop. So this is the closed part. So in this case, KVL is applicable only the circuit is in the closed path, right? So A, B, C, D. So this path is in the closed loop, closed path. Some resistor arrangement is there. So each resistor arrangement voltage drop we are going to measure, and then we are going to add up in one direction, clockwise or anti-clockwise direction. In the algebraic sum, sometimes it may be the plus voltage or minus voltage. So you take it as an algebraic sum that will equal to 0. That is your KVL, right? So some of the procedures or steps to be follow to analyze the mesh, right? First of all, if the given circuit, you need to identify how many closed path is there, right? After that, I'm going to assign the loop current for individual closed path. After that, I'm going to indicate the current direction, but here you have to think about and assign the current direction as the same for all the loop, either the clockwise direction or anti-clockwise. For the convenient, I usually take it as the clockwise direction. Current flow of the loop is clockwise direction. Apply the KVL and form the individual loop equation. By solving the individual loop equation, you will get the each loop current, right? So we will see with the help of some simple example. So this is the circuitical representation. What they are going to ask is what is the voltage drop across the 40 ohm resistor. I'm going to apply the KVL, that is mesh analysis, to find the current through this 40 ohm resistor. If I know the current, I have a resistor value. By applying the Ohm's law to find the voltage drop across the 40 ohm resistor, right? So no need to bother about the current direction represented in the circuit. We will match this current direction at the end of that um, solution, right? First of all, what I mentioned, find the number of loop in the circuit. So here how many loops are there? So this is one of the loop, in the sense, so where you are starting and end points are same. So this is my starting. I'm going to travel across that path and I'm going to meet the starting point. So this is my loop. So likewise, I'm going to find the number of closed path in the network. So this is the first loop. So this is the second loop. So after observing the number of loop present in the circuit, I'm going to assign the current. So for the first loop, I'm going to assign the I1 is my current. For the loop 2, I2 is my current, right? So second point, so assign the current in each loop. After that, all the loop current must be in the same direction. I'm going to take it as the clockwise direction, right? So clockwise direction. So this is also okay. So after that I'm going to apply the KVL. So in this loop 1 I'm going to apply the KVL, Kirchhoff voltage law, KVL, to form the equation. So here, before moving to this applying the equation, so one important point, so here is the resistor, right, R value. Suppose if the current is enter into that resistor, so what I'm going to do is I'm going to take it as this is my positive terminal, this is my negative terminal, because algebraic sum of the voltage drop across a loop equal to 0 is my KVL statement. So sometimes there is a potential rise and then potential drop. So here in this resistor is a bidirectional element, they won't give any polarity. Sometimes they may be give the polarity. If there is not given polarity, you have to take it as current entering the lead is the positive, current leaving lead is the negative, right? So likewise you just mark it as a plus and minus. So current is clockwise direction, plus minus, here also plus minus. Now I'm going to apply the KVL. So I'm start from this negative terminal of the battery, so negative to positive, so negative to positive raising potential, so that I'm going to measure plus 10 volt, right? Here positive to negative, the current is passing from positive to negative, which means fall in potential, drop in potential. So minus 10 into I1. So 10 is the resistor value, I1 is the loop current, right? Next one. So look at here, in this particular branch, 40 ohm is common for loop 1 as well as the loop 2. So at the time, so you have to take it as resultant current passing in this 40 ohm resistor. I don't know which current is higher value. Now I am applying the KVL in the loop 1. I am going to predominantly, I am considering I1 current is the dominant current. So that I am going to write the equation I1 minus I2. So you look at here, this is my I1, right? So coming from top to bottom. So this is my I2. It is coming from bottom to top. So both the current are in opposite direction, I1 and I2. So that I am going to represent I1 minus I2. So this is the current, 40 ohm is the R value. So voltage drop equal to 0. So this is the KVL applied in the loop 1 to form the equation. You just take it as all the terminology, all the term of that equation are representing the voltage. So V 10 volt is the battery voltage, so R into I. So this is also representing the voltage. So 40 into I1 minus I2. So ultimately it gives the current value only. So 40 is the resistor value. This is also V. So if you simplify that, you will get this equation. Similarly, if I am going to apply the KVL for the loop 2, I am going to start from this point. So from here, my current is over here, going here. So as mentioned earlier, so this is my current entering terminal, plus this is my current leaving terminal. So minus what current is passing in this 20 ohm resistor, I2. So minus 20 I2. So here look at here in the battery. So battery, the current flow is positive to negative. So that I'm taking it as the minus 20. So for the common branch 40 ohm resistor, I'm applying the KVL in the loop 2. So I2 is my dominant current. I2 minus I1. Why I2 minus I1? Because both the current are in opposite direction. I2 minus I1. So minus. So for this loop 2, this is my plus, this is my minus. Current flowing from positive to negative. So negative 40 I2 minus, if you simplify this equation, you will get the equation 2. Solving these two equation, you will get I2 equal to 0.428 amp. I1 is the minus 0.144 amp. So which result indicates what we assume the direction is opposite to that result direction. So actual circuit direction, how it look like actually the circuit direction. So this negative sign indicates actual in the circuit the current direction is anti-clockwise direction. So this I2 which indicates also anti-clockwise direction. So what we mention is what we assume is entirely opposite to the resultant current, right? As per the equation, so you look at here, as per the equation, I2 represents in the diagram is opposite of what we consider. So I2 is 0.428 ampere. So right, 0.452 ampere. So current through 40 ohm resistor I3. So this is the positive, this is the negative, opposite direction. If you subtract these two, you will get the current through 40 ohm resistor is 0.284 ampere. So what the question is, what is the voltage drop across the 40 ohm resistor? V is equal to, so 40 into I3. So if you multiply these two, you will get the potential drop across the 40 ohm resistor. So this is about mesh analysis. The question which will help you to recall the concepts. The mesh analysis is based on, right, Kirchhoff voltage law, right? How many loops in that circuit? So 1, 2, 3. So 3. So what is the current flow in the 6 ohm resistor? 6 ohm resistor as shown in the figure. If I1 is the 1 ohm, I2 is equal to, so 1 ohm is carrying the I3, 4 ohm is carrying the I2. So there is no representation of the current, so data is not sufficient. Okay, data is not sufficient. Applying the KVL in the middle of the loop, what is the mesh equation as shown in the figure 1? So what were the I1, I2, I3? So here I1, I2, I3. So I am applying the KVL here. I2 is my dominant. So what happened? I2 minus I1, I2 minus I1, I2 minus I3. So this is the correct answer. Thank you.